In version 5.1, one of the things that we've added is a bit of an improved interaction with our plotting, and also updated our clustering algorithm. In this video, I'll demonstrate a little bit how you could possibly use this for multi-element analysis. So here we have a dataset with some mineral information. We got a number of different minerals. We have some assay data as well. So we mainly focus on the copper data here, but we have some other elements. And how this works typically is that you create an interpolation of the element of interest first. So what we've done is we created an isotropic interpolation of our copper grades. If we go to a threshold here, so you can see different thresholds. So we use isotropic interpolation because it's almost a bit like a distance from the high grades that you can use for your classification. And we'll use this information in our clustering. We'll take the mineral data here, and then under volumetric modeling, you'll see the tool experimental clustering. So we add that onto our workflow here, or on our canvas, set up the workflow and double click on the experimental clustering. What you need to set up is a reference function, so in this case, copper grade, and some thresholds. So what these thresholds do is actually group all our data according to low, middle, and high grades. So you could set them the same if you just want to have two groups, but I'll set them to 0.7, 0.7, and 1.5 here. So you can verify for yourself a little bit if this makes sense with this data. I've set it to 0.7 here, so we classify everything below 0.7 as low grades, all the way up to 1.5. So only the high grades will be included here. All the mineral data in here with all of its attributes will be grouped into these distinct groups, and it will determine the cluster center, and then for every point in our data set, it will estimate how far that point is from any of these three cluster centers. So I click OK, and it's going to take a while, so I'll pause the video. If I start doing this, you can see that it starts preparing, but it takes a little bit of time, so I'll just pause the video while it's doing that. Alright, so this is just finished processing. What it actually does in the background is actually using a covariance similarity measure between every point and every other point based on all the elements that we have in our list here. So now we disable this one. Now we have a new item at the top here, and we can start coloring them based on the cluster values if we want to. These are the high grade clusters, middle grade clusters, and the lower grade clusters. Let's focus on the high grade clusters. And one of the interesting things you can do from here is actually bringing up the plotting dialog. There's different ways you can actually look at scatter plots, comparing the high grade clusters with every different element. But what I'd like to focus on here is actually go to the parallel plot. Maximize this here. So I've included all the elements, so you can see that there's a number that we probably don't need to include. So maybe I'll just close this one, and I'll take a number of these ones out. Not as relevant. Let's use this. We still have a few that are not quite necessary, but let's focus on these ones. So here we see our high-grade clusters. Low-grade clusters actually appear next to it, all the way to the middle grades. If we click on an axis, we can actually create filters. So we can click and drag along the axis. If we then go to our 3D view, you can see that it highlights the points in our 3D view at the same time. So one of the things you can see here is if we maybe focus a little bit on the slightly higher grade. The clusters for the high grades also have a number of points that are actually in the lower grades, which is not what we want. So we create a second filter here on the second axis and filter those as well by dragging along that axis. So this way you can make subsets within your data. You can say, okay, I want to have these ones, these ones. You can see that we have the highest grade cluster here with a low grade cluster here, and you can see how they spread out. And what's quite interesting to see is that most of them actually appear in the high bornite region, and none of them have relationships to the chalco site, and only a limited relation to low-grade chalcopyrite. So if we click on our selection tool here, you can actually make them a little bit bigger so they will show up a little bit better. So now we can actually show in 3D which points are related to our clustering analysis and to which elements they are linked. And what you can do next, if you went through this and built it out your data, is that you can actually use this subset if you think that this is part of a domain that you want to model. You can actually clear workflow here, so we can take this. We have this selection dialog, and you can see that there's a selection here called plot selection that's been created automatically when you created your selection in the plots. If we take this data, we can extract those points using a tool. Down here in the tools, there's extract manually selected points. So we set up the workflow. Say, okay, this is my selection. We use the manually selected segments, and here we use that same plot selection that we've just created. Click OK. Go back to our 3D view. So now you can see that we only have data for the selected points.